G'day guys, Sean here. We'll give everybody 2 or 3 minutes, I guess, to log on, and then we'll kick off. Yes, 2 or 3 minutes, and we'll launch. Thanks.
G'day everyone. Welcome to week 2 of the Dash to Cert office hours for the Associate Cloud Engineer and the Cloud Architect Professional exams. Now, as usual, you've got myself, Jordan Gregg, and Sean Bedford to run through today's office hours, doing a bit of a recap of last week, a few updates of the program and how we should be tracking. As well as what you should be expecting and completing this week, being the Essential Cloud Infrastructure Core Services Coursera module. At the end, common format will be running through a Q&A and a questions component. So feel free to go to this Google short link to fill in a form and fill out any questions you might have. As well as that, you can ask live questions in the Q&A doorway on YouTube, on the YouTube live link. Now, quickly looking at an update of where we should be with this program. This is the 3rd week out of 7 weeks of the Dash to Cert program. And this week you'll be focusing on the Essential Cloud Infrastructure Foundations module. And there's roughly 8 hours worth of effort for this module. Now, last week you should have completed the core platform fundamentals, which was around 8 hours worth of effort. And it was really awesome to see as well the amount of, I guess, input in the Google Plus community and the amount of feedback and help being given out. Keep that up. Now, briefly touching on a recap from last week. The GCP fundamentals core infrastructure really covered the concepts of regions, what zones are, as well as what a virtual private cloud is and how to sort of interact with the GCP platform. So the concepts of Cloud Shell and access and the web UI. As well as that, you touched on the fundamentals of IAM, storage options, so from your VM and compute sort of storage options to your object storage, as well as the different compute options available to you. So these were sort of the key points, and they're very foundational to GCP as a whole. Now, this week, you're going to be focusing on the second module of the series, being the Essential Cloud Infrastructure Core Services module. In this module, you're going to be covering projects and networks, as well as the VPC, Virtual Private Cloud networking, as well as that VMs. So it's very much geared towards the foundational piece, as last week was. So jumping into projects and networks, I'll hand this one over to Sean to start guiding through what's to expect this week from this module. Over to you, Sean.
Thanks, Jordan. 1 second. Just make sure we're presenting here. All right. So projects and networks. So thanks, Jordan, for the recap. So last week was really just a bit of a whirlwind tour around GCP services, and now we're really starting to kind of dive into the details, right? So all the things that you covered last week was largely kind of the high-level kind of introduction. This is what a VPC is. This is what a project is, with some kind of key points, I suppose. However, what we're going to do today really is, and this week in the general course material, is dive into a little bit more detail around how these things operate and what you can do with them. So we've got obviously a summary of the content here just to kind of introduce it and get you guys ready and familiar. So let's dive into it. So projects and networks. So as you saw last week, the project is effectively like it's a container, right? It allows you to isolate your resources and group things up effectively under the banner of kind of access and isolation. All right, so you can see there on the slides, a project associates objects and services with billing and contains networks. It introduces an important element there. As you can see, there's a quota maximum of 5 networks that you can have in any one project. And quota is something that's important to understand, as these are kind of like the soft limits that you can place on a project to control the resources that can be effectively set up and consumed under a particular project. And no, sorry, I was just checking the YouTube chat, so everyone I think is okay. All right, so as you can see there, right, yeah, you have VPC networks, and those networks come in and are associated with projects, right? So a network in and of itself, it doesn't have any specific IP address range. As we kind of saw last week, the address range really comes in from the subnetworks. The network itself is global. Again, right, it doesn't have an IP address range. It's global. It has the potential to span all available regions. It's not until you actually bring a subnetwork into play that you then access both, you set up an IP address range and you lock in a particular region. So again, I've got a diagram on this in a second when we dive into the details of VPC networking. But you can think about a subnet is specific to a particular region, and a network can span regions by having multiple subnetworks. There's another interesting point there of when you create a network, you can set up basically the subnetwork, the way in which subnetworks are created. And I keep saying subnetworks like that's a word. Let's go with subnets. So you control the way that subnets are defined. And you can either set it up, which is in the default way, you can leave it in that mode, which is auto. And what that does is it goes and creates a whole bunch of subnets for you, one for each region, with some kind of default CIDR maskings. Or you can go in there and create effectively a custom mode VPC network. And that allows you to control down with a lot more fine-grained precision the regions that are available and the IP address ranges, etc. So let's dive into VPC networking in a little bit more detail. So these are probably the 9 most important things that you need to know around VPC, or I guess the objects that are associated and used in VPC networking. So obviously we've spoken about networks, and we've spoken about projects, and we've spoken about networks, and it's really important to understand, as I said before, right, your networks are global, your subnets are specific to a particular region, and you can have networks in either a default mode or an automatic mode. Sorry, you can have them in the default automatic mode or in the custom mode. And once you've created a custom mode entity, once you've created a custom mode network, you can't go back, right? So you can start as auto and then flick that to a custom mode and allow you to kind of change and control things. But once you've got a custom mode, we don't support you to roll back to an auto mode. You have to create a new VPC and kind of map things over. So from the other objects that are important, obviously regions and zones. We spoke about them last week. It's fundamental to understanding how GCP works, especially around networking. We've kind of touched on that. Your IP address range, both your internal and external, and the total addressable range on the individual subnets. Your VMs are always associated up into particular subnets and particular networks. And we'll touch on that a little bit more detail towards the end of the office hours, and you'll see a lot more detail in the Coursera material this week. But finally, the other 2 most important things to get your head around, and we haven't really touched on this too much, is around the routing between networks, as well as the firewall rules. And you can see some of the you'll see throughout this week some of the kind of the nice features that we have in GCP around how you can define routes and define firewall rules in a really kind of flexible way that reduces kind of the operational burden of running these services. So there's obviously a whole bunch of other things that you can do in VPC, right? This isn't obviously an exhausting list. There's a lot of other things that you might need to be able to do, like IP port forwarding and load balancing and potentially protocol forwarding, or DNS type services, VPN services. But the thing to understand is that they're all kind of built upon these fundamental building blocks of VPC networking. So regardless of whether you're doing the cloud architect or the associate engineer exam, it's really important that you have a really solid foundational understanding about how projects, networks, subnetworks, regions and zones, IP addresses, your routes and firewalls, tagging when we get to that, how all of these things operate, because it is obviously really foundational that a lot of the services that we're going to discuss over the next kind of 5 weeks are built upon. So from a traffic perspective, you just kind of need to know this stuff. The way to explain this is, and there's a diagram I've got on the next slide which kind of illustrates this really easily, is that for ingress, obviously there's no charges. However, when you're talking about egress, anything that transits over the public internet, you're effectively paying. You're paying plus the between regions in the same zone. So that it's just important to understand from an associate cloud engineer exam. I don't think it largely matters because it doesn't affect how you actually go about building solutions. However, when you're in the cloud architect stream, it's important to have cost as a consideration because you will be asked to compare and contrast around what is the most cost-effective solution, and you will need to factor in things like egress costs as part of that solution. So this is the diagram that I alluded to before, and I think you saw this last week as well. I think this is just a good diagram that kind of just illustrates how all of the things that we've spoken about over the last kind of 3 slides or 2 slides come together. So again, here, as you can see, right, you can use networks to isolate systems. So in this example, we've got a project with 5 networks, and those networks, as you can see, span across the 5 regions that are set up there. So this would be a bunch of custom networks that have just been basically set up to have these 5 regions. Because obviously, if you did an auto one, you would have Australia East and all the other regions come in, and we'll ignore the ... right? So that just gives you an example about how projects, networks, and subnets are sitting along. Obviously, subnets are the green boxes, and how you can deploy resources inside particular networks that may be deployed in different subnetworks, but they can communicate over internal IP addresses. So in this example, if you want to make sure that system C here, which is the little compute engine instance in network 3, can never communicate with system D except over the internet, you place them in separate networks. So again, networks there are used to kind of isolate resources in this respect, so that you don't have that kind of cross communication. For C and D to communicate, they'd be going, and you'd be liable for egress charges for anything, any kind of traffic that communicates, that flows between those 2 resources. The traffic isn't actually touching the internet per se, but it is going through the Google Cloud Edge routers, so it's got different kind of billing and security ramifications there. Any VM resources that you deploy that are in the same network, so in this case you've got A and B, they can communicate with each other over internal IPs, even though they're in different regions. So you can see there's just some differences there, right? So A and B can talk over internal IPs, C and D talk over external IPs, even though that traffic still routes within the Google Cloud Network. So we've got a couple of examples, I guess, about how you can set up I guess, different resources in different kind of configurations to meet particular, or just how you can kind of demonstrate different capabilities, right? So we start here with availability. So again, you can see we've got 2 virtual machines running in 2 different regions. And you can see there, so subnet 10.2.0.0, it crosses zones within a region. So, sorry, these are not separate subnets. This is one particular subnet that's going across multiple zones. So as you allocate the virtual machines into the different zones, what you get out of that is that fault isolation, and it increases the availability of that service. So if something was to happen to US West 1B, the service is still available because it's been deployed in US 1A. What you can also do there is use firewall rules that can be written against the subnetwork, and then using tagging on the resources themselves, you can apply that to both servers, even though they're in different zones, right? So this ability to have a really kind of software-defined approach to routes and firewalls provides that flexibility that just gives you basically just reduces kind of the operational cost, right? Makes it easier to get up and running. So this is an example of how you can deploy resources in a VPC for availability. We deal with globalization, however, right? So here you can see we've got one particular project. So everything's grouped up under one particular project, and it's all contained in one VPC network. However, it's in multiple regions and zones. So putting resources in different zones in a region provides that isolation. It doesn't really matter what you're deploying, right? It gives you the ability to have that isolation. So those two services here, they're still able to communicate, but they're effectively isolated resources. So you can control that through a bunch of different ways that you have. So specifically in the example, the VMs, even though they're in two different networks, you've got your subnetworks that are limited to a particular region. So you can't get the benefits of a single subnet across both regions as you could with a single subnet encompassing zones. So if you want global availability, having kind of failover VMs that are in different geographic regions, perhaps, there's a little bit more complexity involved that you need to work with. So notice that because these VMs are in a single network, even though they're in different zones, they can still communicate through GCP's internal global network. So what that provides is that performance while also kind of balancing the availability and reliability of that solution. The fact that it's deployed across multiple regions gives you that globalized presence, but you've got the ability to be really discreet around how you secure resources while also providing a really kind of low latency service. All right, running through all of these examples is super exciting, and the Coursera material will explain this a hell of a lot better than I will. But the last one here that we want to go through is around management separation. So if you remember back, a few slides, and we were talking about some of the key kind of fundamental concepts. When you talk about the key fundamental concepts, right, it was around projects provide isolation. So projects encapsulate resources, they separate out billing, and they separate out things like identity and access. So by putting your resources in separate projects, that effectively isolates your virtual machines, right? So it can be useful for identity and access management, as I said, and also for billing purposes. So in this example, if you've got project one on the left-hand side is doing some software development, and project two might be doing some tests or test automation or engineering or something like that, you can have completely different people that are assigned to different roles in those projects. So you can consider dividing systems up into multiple projects for better access control and transparency. But since the network can't span projects, you need to go out over the public internet. There is one caveat to this slide, and that would allow you to have multiple projects for isolation with effectively shared kind of networking across those, and that's where you get into shared VPC style projects, which is covered in the Coursera material. I don't have a slide, but I just wanted to point out that this isn't a kind of, it's not a completely kind of black and white thing, right? Even though you might want to have the isolation and control of having resources deployed into separate projects, you can still have some shared networking sit across using VPC projects. So it's an important thing to be aware of. Connecting up networks. So, we might have some on-premises resources. We might have different resources that are shared within Google Cloud, as I mentioned before about shared VPC, or you could be dealing with resources that are deployed across other public cloud providers. So we've got to have different tools available to us to handle those different use cases. So as you can see there, within Google Cloud, we've got the ability to have shared VPC, and that allows us to share our VPC network, our subnets, all that kind of stuff across multiple projects within the same organization. So that was basically the scenario that I was talking about before. You can also use VPC network peering, which allows organizations to connect their VPCs without using any external IP addressing. So it's just kind of like a peering approach that just allows two VPCs to talk to each other. When we're dealing with hybrid connectivity, either cloud to cloud or on-prem to cloud, there's a couple of different ways that we can go about doing that. We'll walk through them in a second. So we've got VPN. Obviously, it's fairly kind of fairly standard approach for connecting things up. So that allows us to connect our on-prem and VPCs across the internet with a level of security in terms of transport level security between the on-prem resources in our public cloud. And we have the ability to use that either with or without dynamic routing. When we talk about interconnect, that's effectively where we're physically connecting a data center into physically connecting your on-premise resources with your VPC network. And you can do that either direct by having a your router in a location that Google is connected to, and having that the connection done there, or done it through a partner like a Megaport or an Equinix or something like that. And finally, we've got peering, which is basically gives you the ability to physically connect your on-prem environment to public Google Cloud IP addresses only, and all of that information is public. So let's dive into that and have a look. So here you can see we've got a setup of Cloud Router. So this is doing some BGP routing from your on-prem resources using a VPN to provide effectively kind of allows your on-prem resources to connect to and talk to your resources that are deployed in the cloud as if they were kind of over over private IP address space. So this is one way in which you can deploy kind of hybrid style solutions. So any kind of new subnets that you create in GCP or in your peer network are kind of discovered and shared through that BGP address sharing through the BGP updates that you can see in red in the middle there. And that's what allows the connectivity between both peers on their entire networks. So when we talk about actual peering solutions, this was kind of like one of the bullet points on the previous slide. What this allows you to do is basically build kind of software as a service style ecosystems on GCP to make your services privately available across different VPC networks in and across organizations, and basically allow your resources kind of wherever they are to communicate in that private address space. So it's useful generally when you've got several network type domains that you need to be managing independently, but you still want them to be able to communicate, or if you need to connect with other other organizations that you might need to talk to. So I think the next slide is around direct peering. So this is the first one, the first option that we've got to talk about. So we've got direct peering and carrier peering, if you remember from the options we spoke about before. And apologize if we're running through this really quickly, right? Coursera goes through this in a lot of detail, and there's some good examples about how you work through these specific scenarios. This is largely just to confuse you enough to go to Coursera and spend a little bit of time digging into it. So direct peering. Basically, Google allows you to create a direct peering connection between your network and Google's network. And this is effectively the connection that you exchange your internet traffic with. And the way the connection works is obviously it goes from your company network, either your headquarters or from an external data center, through a peering router, which is connected to or which has the BGP routes, I should say, shared with Google's peering router. So it appears almost like you're transparently connected to Google's Google's network. So there's some obviously the benefits here is around kind of routing and latency, right? So you're not having to hop out onto public internet and go through a whole bunch of hops to get to the next Google Cloud point of presence, but you're able to kind of go directly there. When we talk about carrier peering, however, this is basically you're going through effectively a server provider type relationship. It's effectively kind of the same thing, more or less. There are some minimum requirements generally around the carrier. So when you're dealing with direct peering, there are some requirements that we place, and they're all public on our Google Cloud Docs site, and I'll just post that to the. Let me just post that to the link. So there are some requirements that we place around direct peering. So one of the benefits of using a carrier peering is if you don't meet those requirements, you can basically peer with a service provider, and they can provide the bandwidth requirements effectively to be able to peer directly with Google. So there's a bunch of other stuff. I think it's covered in detail in Coursera when we talk about interconnects and partner interconnect and how those work. We don't have slides on it just on the interest of time. But basically, from an interconnect perspective, that's the thing to remember there is that peering is always done kind of at the software level. You're doing you're effectively changing the way packets are routed. Whereas when you're doing interconnect, as the name kind of says, you're physically connecting a cable either directly or through like a co-located facility or a data center that Google has through its partner networks. And generally where you want to start to use partner interconnect is when you want to slice down the bandwidth, because direct interconnect has, from a cost perspective, the cost can be reasonably high. The bandwidth available is quite high. So a way to offset that cost, again, from a professional cloud architect level, you might want to use partner interconnect, because then you can say, I don't want, I don't want X bandwidth, I just want kind of 10 meg bandwidth or whatever it might be, right? And you get the cost benefits of that. All right, virtual machines. So the next point that we want to talk about is virtual machines. Again, I think there's a whole course dedicated effectively to how to use the Google Compute Engine service on Google Cloud. So we've only got kind of 3 or 4 slides, I think, on VMs in this office hours, but there is a whole bunch of content on Coursera, and there's also a number of different labs that you can go through, which kind of talk through how to set up virtual machines, how to connect them up into networks in various different configurations, talking about security and images and all that kind of stuff. But we'll dive into it. So as I said, it's all about infrastructure as a service, virtual machines, and Google's offering, as we saw last week, was Compute Engine. As we step through all of the Coursera material, you're going to cover all the different compute options, right? Both exams will test your knowledge on how to deploy or architect solutions in Compute Engine, all the way through to kind of potentially cloud functions, depending on the exam you get. So it's important to understand how these things work and how they're different. So we'll start with Compute Engine, and I think next week we're diving into some of the app services, or it could be the week after. So look, Compute Engine kind of on one slide. There's so much material, I guess, to cover on a raw VM. What's important to understand from a kind of a top level perspective on Compute Engine, there's effectively 2 classes of virtual machines, right? You can have a standard virtual machine, which is as you would expect in a normal infrastructure as a service provider, in that you start the machine and it runs until you tell it to stop. One option that we have on Google Cloud is the concept of a preemptible instance. And this is the instance that gives you a large discount. However, the uptime, there's no kind of, it says there's no SLA there, right? There's not a service level agreement, because the expectation when you take a preemptible instance is that it will run for no more than 5 minutes without being reset. So it's kind of similar to a spot instances type environment on Amazon EC2, right? It's that kind of solution. So if you think about it from the top level, we've got our standard instances and we've got our preemptible instances. When we drop down into the images, in terms of what kind of operating system we're going to run, there's all the standard images that we support. So you've got your Red Hat Enterprise Linux, we've got our Windows images and so forth. So it's worth being across those. We've got the ability to assign metadata, and I'm pretty sure from memory there's a bunch of labs that go through how you can use both instance metadata to set up firewall rules and routing rules, as well as using startup scripts to deploy dependencies on machines, which is particularly important when you get into managed instance groups and how those solutions scale out. However, don't be surprised if you don't see the managed instance groups and scaling elements of the Compute Engine handled in this week's content, because there's a whole set of material on that's coming. Google does have an important feature in its Compute Engine environment, which is the concept of live migration. So what that means is that from a security perspective, from a reliability perspective, we effectively patch and update, restart hosts that your virtual machine might be operating on. However, your guest process just moves across from one host to the other. And we call that concept live migration. Again, there's a lot more detail in Coursera, but one thing just to be aware of is that happens transparently and there's no downtime or no outage to the customer. From a machine sizing perspective, again, we have your typical machine sizes that you might have. We could have, an M1 instance that has, one virtual CPU and 3.75 gigs of RAM. However, we also offer the ability to customize that. So you might say you need a smaller amount of virtual CPUs, but more memory, or vice versa. So you've got the flexibility to customize or right size the machine to exactly what you need. And then we also run a process to provide recommendations on where your machine should be sized based on the usage pattern. So the more you use the solution, the more data we have to make those right sizing recommendations accurate. Again, there's a whole bunch of labs to walk through about using GCE as a bastion host into private networks and all this kind of stuff, right? So do take advantage of the labs that are in Coursera. And also we posted a link to some labs on the Google Plus community, some credits for quick labs. And again, there's a bunch of compute engine focused labs there as well. So yeah, some of the checklists, some of the things that you need to be aware of, right? Make sure that you understand standard versus custom machine types and how you can take custom images and deploy those into Google Cloud Compute Engine. How do you attach disks to your compute engine? So I didn't cover this on the last slide, but we've got hard disks. Sorry, I'm tripping over my own tongue. We've got solid state drives. We've got local solid state drives. We've got transient disk. We've got persistent disk. There's a bunch of concepts, I guess, that you need to be aware of. The different kind of trade-offs between how those might operate, whether it be from a reliability perspective, whether it is from a performance perspective, whether it is from a cost perspective. Being able to compare and contrast those for on the Professional Cloud Architect exam is really important, as well as from an ACE perspective, knowing how to actually provision compute engine resources to take advantage of these features. Understand images and snapshots. We haven't gone into kind of snapshotting and backups. But that's definitely covered throughout the Coursera material. The billing implications, right? Again, for Cloud Architect, I covered this, but understand how the consumption charges work, what levers and options you have available, and how those options and levers affect the consumption costs that you will be up for. And finally, just basically how to operate resources in the cloud, right? So whether that's using tags and metadata and labels, to drive out potentially deployments in a managed instance group, automatically deploy routes and firewall rules and a whole bunch of other different things, right? But just being across those elements and how they interact, along with kind of startup scripting and all that kind of stuff to get your environment into the right shape. So any questions? We'll jump over to the Google form. If anyone needs the link again and they want to put something in, I'll just post it again. And I'm going to go on mute. And Jordan, if you can run through some of the questions for me, that would be great while I have a drink of water. I think Jordan is not listening to me. That's not very nice. All right, I'm going to go through the questions then. So I've got a couple of questions about Coursera Access again. Apologies, there are still some questions about Coursera Access. I've been away the last couple of days overseas. And I've got 1,000 different emails, right? Please, if you don't have Coursera Access and you registered by completing the form that was sent out, it was on LinkedIn. It was sent to all your partner managers. If you didn't complete that form, if somebody just forwarded you an email and you requested to join the Google Plus domain, you don't have access to Coursera. You haven't been requested. It's probably too late. And if you've sent me an email and I haven't replied to you, again, it's probably too late. However, if you completed the registration form, everyone who completed the registration form should have access. So if you think you should have access and you don't, drop an email to Coursera support and ask them to either reset or unlock your account, because everybody who registered has been provided with a token from our side. And unfortunately, just the way Coursera works, that's as far as we can go. Again, there's a question here about I'm unable to complete the Coursera course by tonight. It says it's due 27th. Don't stress about it. Those are just guides. I would recommend that you don't get too far behind on the Coursera work because as you can see, right, it's kind of the first week of real work and you're already struggling to get into it with the real world. I understand that gets in the way, but trying to let it get too far on top of you because it will be hard to complete it. But rest assured, Coursera won't kick you out if you don't complete it by the due date. Question, do VPCs span regions and subnets don't? So VPCs are global. They span all the regions, or they have the potential to span all regions, and a subnet effectively allows you to have an IP range in a particular region. I hope that addresses the question. Could you clarify the different questions, the different connections? Okay. VPN over internet. Yes, it is a software-based VPN. You run a service inside your network called Cloud Router and Cloud VPN, and that effectively establishes a VPN connection. Direct peering and carrier peering. So again, these are, let me start with interconnect, right? So as I said before, dedicated interconnect is you're connecting a physical connectivity. And again, I hope I don't stuff this up because I always get this stuff wrong. And I'm not a deep networking person. Coursera does go through this really, really well. So don't stress if I'm confusing you with my explanation. But basically, direct peering and carrier peering is effectively like an exchange of routes. And either you do it directly with Google, or you do it through a carrier. When you're doing with dedicated interconnect, you're going through a physical connection, which is connected either to a partner like an Equinix or a Megaport or something like that. And then so your connection is to there, and then they're connecting you with Google, or you're doing direct connection where your local data center supports the requirements and I guess needs the bandwidth that we offer through direct connection. I hope that explains the connection. Explains the differences. But again, Coursera has this explained really, really, really well. And just in the interest of time, I'm going to move on. Preemptible VMs are exactly like spot instances, more or less, just without the administrative overhead, right? So you don't have to, I guess, put in a bid and manage all of that. You basically just create a preemptible VM, and you get a message that your application basically gets a message saying it's going to be restarted in, I think it's 30 seconds, and you have 30 seconds to your application to shut down. The machines shut down and then restart it on a new host, and you get another kind of 5 minutes. Evada said, could you kindly unenroll me? That looks like an email that I've already done, so yes. On hybrid networks, can BGP sync any changes in a database? So it's changing the BGP routing as I understand it. And again, I'm not a deep networking person, so I hope I don't give you the wrong answer here. But it's exchanging the basically the addressable kind of IP ranges and the routes. So if you have databases that are like Cloud SQL that are connected to a VPC subnetwork, gotta stop saying that, a VPC subnet, those should be locally addressable. Template file for creating infrastructure using script. Yes, absolutely. Later in the course, there is a whole course in a module on infrastructure automation using deployment manager and APIs and things. Any clarification on that sweet swag? I think I addressed this last week. There is a swag store. When you pass your exam, you get swag. I finished, again, if you've got any issues with Coursera, please go to Coursera. I can't do anything about it, unfortunately. Who are the peering partners in APAC? Hit up, just in the interest of time, it's all public, so have a look at the Cloud Docs on peering. It goes through that in the Coursera material as well. Your thoughts on the Wallabies performance? Don't follow rugby, more concerned with South losing 3 on the trot before the finals. I work with a few people that have been doing the wrong courses, so by that I mean not the fundamentals, different stuff. Is that an issue, or does it all lead to the same place anyway? Depends what courses, what you mean by the wrong course. Last week was fundamentals. This week is the whatever the course was that I said at the start, which I can't remember the exact name of, but it's the second course in the module. Again, maybe I'll put that up really quickly on the slide just to go through the courses that we should be following. The important thing to understand from Coursera is that you're enrolled in the Architecting with Google Cloud Platform specialization. That is a collection of these 6 Coursera modules. Do we have a sandbox environment with multiple projects and environments within where we can practice GCP functionalities? You've got at the end of each module, in each Coursera module, there are multiple labs, quick labs environments that you can get access to, and I've put on Google Plus access to quick labs. Please have a look and read it. In hybrid networking using VPC, who should control DNS? Yeah, that is a good question. It largely depends. Probably depends on where your authoritative source is, but there's multiple ways you can do it. Probably we don't have time to go into the specifics of that because we're just about out of time. Let me run through it. But yeah, that's a lot. That is a really good question. I'd post that question on the Google Plus community and we'll dig into it. Google Cloud with other clouds connection and interchange of data. Yep. So the connectivity requirements or options that we spoke about before don't just necessarily limit you to on-prem versus into GCP, but also GCP into AWS or Azure. So you have the option to do that as well. All right. if there are any other questions that I haven't covered, or anything else that you feel hasn't been covered clearly in the Coursera material, feel free to throw them up on Google+. We'll try and get an answer to them. Just with the number of people there, I'm glad you guys are answering each other's questions, and there's a few Googlers jumping in and helping out because there's a lot of people and a lot of questions. Please don't ask questions without watching the Coursera module. Do the coursework, throw the questions out. Coursera will explain stuff a hell of a lot better than I will, and you have the option to go back and replay what they say. So please take advantage of the material. Thanks again, guys. That was great. I hope you enjoyed it. Thanks again for your work last week, working through all the material, and look forward to interacting with you on G+, and see you all next week. Thanks a lot. Bye-bye.